Okay, salam sejahtera and welcome back. Okay, so today we will continue with the last second subtopic, 3.8, potential divider. Okay, potential divider. Okay, so potential divider is produce an output voltage that is a fraction, okay, of the supply voltage. Okay, so meaning that dia adalah satu ratio, okay, fraction. So this is done by the connecting two resistor in series and show in the figure. Okay, so meaning that if let's say we have two resistor and we want to find out what is the value for V1. Okay, if let's say this V total is 10, okay, and the resistor is 1 ohm, this one also equals to 1 ohm. Okay, so if let's say we want to find, okay, we want to find what is the value for V1. Okay, so meaning that you must use the fraction. Okay, you must use the fractions to determine the value for V1. Okay, so what should we do is, okay, you must refer here. Okay, you must refer there is a big loop. Okay, this is a big loop. Okay, and there is also a small loop. Okay, meaning that if let's say you want to find, V1, so V1 is your small loop. So this is another loop, small loop. Okay, so you do fraction. Okay, meaning that we use total over the V output. Okay, so we look at the first loop first. Loop yang pertama. Okay, loop yang pertama is we have V equals to IR. Okay, V equals to IR. Okay, tengok yang kuning. Okay, the first loop, the big loop. So because this big loop is involved total, so we take everything total. So in this big loop, our V is 10 and I we don't know. Okay, R total for this loop is 1 ohm plus 1 ohm. So it's equals to 1 plus 1. Okay, is equals to 2 ohm. So this is our first equation. Okay, the second equations come up from where? From the green color loop. Okay, the smaller loop. So the smaller loop, V1, is the value that we want to find. Okay, equals to IR. Okay, since you want to find V1, meaning that you must take R1. Okay, so R1 is equals to 1 ohm. Okay, so this is our second equation. Okay, and then you do ratio. Ratio. So I and I we can cancel. Okay, I and I we can cancel because they are series. They are connected in series. Arus yang mengalir melalui R1, R2, dia adalah arus yang sama. Okay, so we can cancel because R1, R2 is connected in series. So finally, we have the equation where we can find V1. So V1 is equals to, okay, V1 is equals to, what's the value? Is equals to 10 over 2. So it's equals to 5 volt. Okay, so this is how you do it. Okay, so we continue. So since the current flow through each resistor is the same, because current flowing through the resistor is the same because it's connected in series. Okay, so therefore our I total is equals to V total over R total. Okay, and since if let's say you want to find the potential difference across R1, meaning that you want to find V1, okay, so if let's say we arrange back the I, you substitute I inside this I value, okay, you substitute inside this value, okay, you will find out that actually your V1 is equals to V over R1 plus R2, R total lah, okay, times R1. Okay, so therefore we can rearrange back the equation. If you want to find V1, so it's equals to R1 over R total times V total. Okay, similar, if let's say you want to find V2, you must write R2 over R total times your V total. Okay, so this is the equations. Actually, you don't need to memorize the equations. You don't need to memorize. Okay, you just do ratio. Okay, you just do ratio. Okay, so we try another questions. Okay, this is L. Okay, since because the resistor R1, R2 can be replaced by a uniform resistor wire. Okay, so wire is also one of the resistor because our resistor is equals to rho L over A. So meaning that it depends on the resistivity, depends on the length of the wire, depends on the area. Okay, so similar for this case, if you want to find V1, okay, so V1 meaning that we only want to take this loop. This is a small loop that we want to find. Okay, and we also have a bigger loop. A bigger loop is the total. Okay, so this is the total loop. This is the bigger loop. So meaning that we have one loop, we have two small loop. We have two loop, one big, one small. Okay, so kita buat secara ratio. Okay, V total and then V1. So if let's say you take V total, you must take everything total. So you must take L1 plus L2. Okay, if you only want to take V1, meaning that you only take I1, L1. Okay, so this is the ratio. Okay, so if for example, let's say your potential difference for the battery, the power supply, if let's say 20 volt. Okay, 20 volt. And the length for this one, for example, let's say 0.1 meter. And for L2 is equals to 0.4 meter, for example. Can you find V1? Okay, so you just substitute. Okay, so total we have 20 volt. And total length is 0.1, 0.4. Okay, so it's equals to 0.5. Okay, V1 we don't know, but we know that L1 is equals to 0.1. Okay, so meaning that your V1 is equals to how many volt? Okay, how many volt? 20 over 0.5. So this one we cancel off. So meaning that your V1 is equals to 4 volt. Okay. If let's say V1 equals to 4 volt, meaning that your V2 will equals to 16 volt. Ratio lah, ratio. Okay. Or you can take 20 volt minus 4, you'll get 16 volt. Okay. So thus, we also can write as, okay, since your R is directly proportional to the length, okay, assumes that we are using the same material, meaning the resistivity sama because same material and same area. So your R is directly proportional to the length. Okay, kita boleh buat ratio. So if let's say you want to find, V1, so you must take L1 over L total times your V total. If let's say you want to take V2, you must equals to L2 over L total times your V total. Okay, so we try example. Okay, we try example 14. Okay, so example 14 very clear. We have a two loop. Okay, kita macam ada two loop. Loop yang pertama adalah yang besar. Okay, this is the big one. So 12 volt is, okay, is distribute to 8,000 ohm and also 4,000 ohm. Okay, if let's say you want to find V output from the 4,000, okay, for 4,000 ohm, so this is another small loop. Okay, so we have big and small. So calculate the output of the voltage. Okay, so for this case, it's very easy. We take V total, big loop, over V, let's say this is V1, okay, V1, okay, equals to IR. Okay, so for bigger loop, I is, I we don't know. R total, because this one, whole thing is number 1. So it's 8,000 plus 4,000. So this is V total. Of course, this one you must take R total. Okay, over the second loop, the smaller loop, is V1 equals to IR, and your R only 4,000. Okay, we can cancel off the I. Okay, next time if you don't want to write I also can, because I are the same series. So you can cancel off the I. Okay, and your V total is equals to 12 volt. So can you find V1? Okay, so we do ratio. Okay, kita buat ratio sahaja. Kita buat perbandingan. So you will find out that actually your V1 is equal to 4 volt. Okay, if let's say you want to find V2, can you find V2? Can you find V2? Of course we can. V2, either you take 12 volt equals to your V total is equals to V1 plus V2. So your V total is 12, your V1 is 4. Okay, meaning that your V2 is equals to 8 volt. Okay, 8 volt. Okay, or if you don't want, you also can do ratio. Okay, ratio meaning that we take the big loop and the small loop. Okay, you also can do ratio. So this is the ratio, another one we can do. So meaning that we compare yellow and green. Okay, yellow and green. So if let's say you want to find V total over V2, okay, equals to, V total is 8,000 plus 4,000. Okay, the total resistor. And the resistor for V2 is 8,000. And of course, our V total is equals to 12 volt. Okay, you substitute inside. So your V2, you will get, okay, your V2, you will get 8 volt as well. Okay, you will get 8 volt. Okay, so this is, if let's say you want to find V2. Okay, next, if the voltmeter of the resistor 4,000 connected across the output, determine the reading of the output. Okay, if a voltmeter of resistor, okay, meaning that if there's a voltmeter and the voltmeter inside there is a 4,000 ohm connected with the across the output. Okay, so meaning that, okay, wait, okay, meaning that this is okay, and there's a voltmeter. So this voltmeter, there's another 4,000. Okay, this is your voltmeter. Okay, voltmeter. But this voltmeter, we have a resistor of, okay, a resistor of 4,000 ohm connected, okay, across the output. Okay, so what should we do is, we try to simplify it. Okay, kita cuba simplify it. Okay, kita cuba simplify it. Okay, meaning that this one, we try to simplify it. Okay, become, this one still 8,000. Okay, so if we try to simplify it, just now this one is 4,000. Okay, and it's connected in parallel. So 1 over 4,000, 1 over 4,000 plus 1 over 4,000. Okay, so your R now become, okay, your R will become 2,000. Okay, become 2,000. Okay, so here become, okay, if we try to simplify it, here will become 2,000 ohm only. Okay, so what is the reading for the voltmeter? So similar, if you want to find what is our V1, okay, but now our resistor, if you compare your V1, no longer the resistor at here no longer 4,000 because there is a 4,000, 4,000. Okay, 4,000 for the output, 4,000 for in the internal resistor inside the voltmeter. Okay, so we need to recalculate. Okay, we need to recalculate. Okay, so similar, we also have two loop. Okay, the bigger loop and the small loop. So the first loop is 12 volt and the total resistor is 8,000 plus 2,000. Okay, and the small loop, this is the output that we want to find. The second loop, okay, V1 is the value that we want to find, and the resistor only 2000. Okay, so you can find your V1. Okay, you cancel off, you will get your V1. If let's say there is an internal resistor inside the voltmeter, you will get 2.4 volt. Okay, you will get 2.4 volt. Okay, so if you don't understand, you can pause the video and calculate again. Okay, so the answer V1 is equals to 2.4 volt. Okay, so that's all for today. Thank you, class. See you on the next subtopic. Okay, bye-bye. Take care.